Hi everyone, welcome to lesson 4 today. Today we got special triangles and the unit circle in our trigonometry unit. So, first things first, what are special triangles? So we have three special triangles here that we kind of taught back in 20-1. Hopefully you kind of recognize these guys. And so how it works is if you had an angle of 30 in a right angle triangle, that is, your two sides will always be 1 and root 3 on your two sides, with your hypotenuse being 2. If you had an angle of 45, your two sides are 1 and 1, with the hypotenuse of root 2 there. And if you had an angle of 60, it'd be root 3 over and root 3 and 1 for your sides, with an answer of 2 for your hypotenuse. So those are all just special triangles, and that is just a cool, very, very quick reminder of what they do, or of how they look, really. Our first question, though, at the 30 levels, what would these three triangles above look like if we changed the radius to 1? So basically, I'm going to divide everything by my radius. So if my first angle here was 30 degrees, and I had a radius of 2, 2 divided by 2 is now just 1 there. So everything else, my two sides will also be divided by 2. So I have root 3 over 2, and I have 1/2 right here. On this one here, this is my 45-degree angle. And again, if I in this case, I'm going to divide everything by root 2. So this now I have a hypotenuse of 1. And on the side here, I have 1 over root 2. And the same thing down here in my denominator, 1, or not denominator, on the bottom really, 1 over root 2. Again, you never want a radical in your denominator. So I'm going to rationalize, and I'm going to show you the work right here. And so that's going to get us root 2 over positive 2. And I'm just going to simply rewrite this one as root 2 over positive 2. There we go. This last one here, we have 60 degrees in this corner. If you had 2 on hypotenuse, that's going to be 1, so I divide everything by 2, so I have 1/2 here, and now I have root 3 over 2 there. And so this here, your special triangles have now been all divided by 1, so that they're all on the unit circle. So on your page here, you have a giant unit circle that we're going to try to fill in together. Again, I'll only ask you to fill this in once as we work on it together. It's easier to memorize just one section of it. Quadrant 1, if you can memorize quadrant 1, you're good. You don't have to always constantly rebuild a brand new triangle, or unit circle, sorry. But let's start you off on how to build this. So here on my most inner line here, these are all going to be radians. I have degrees closest to that outer edge. Then on the outside of that, notice that it's all ordered pairs, so we'll have ordered pairs outside. Let's start with our degrees. If you're and you always have to start on the positive x-axis because it's in standard position. If you're on your x-axis, you're either 0 degrees, or if you're in a full rotation, you're 360. The next one, of course, is going to be 30. And then we have 45, which is smack dab in the middle of between 30 and 60. Right here, making perpendicular to our 0 degrees, is going to be 90 degrees. And we just keep adding 30 everywhere else. So we have 90, 120, 150, and of course 180 if you're flat. Here in between, halfway between 150 and 120 is always 135. And that's 135 degrees. There we go. To fill in the rest of this, I'm going to add 30 again. So that's 210. We have 240 right here. 270, and I'm just going up by 30s everywhere. 300 and 330. So I just added 30 degrees everywhere. So I'm just missing 2 of these, and these are just always halfway in between. So between 210 and 240, I'm at 225. And between 300 and 330, I'm at 315. And there we go. All our degrees are filled in. Let's talk in terms of radian. So if you are 0 and 360 on your x-axis here, you're also 0 and 2 pi on the same axes. If you're 180, you're going to be considered just pi. So if you had 0 on this side, don't worry about the 2 pi for now, but if you had 0 and on one end, pi on the other, halfway between 0 and pi has to be literally pi over 2, because that's exactly halfway. And if you took pi over 2 and divided that in half, now you get pi over 4. Okay, and so if I start counting in terms of fours, here's what I get. I get 0, 1/4, which is pi over 4, 2/4, which is reduced down to 1/2 pi. This is going to be 3/4, which is 3 pi over 4, and 4/4, which is just pi once you clean it up. I'm going to continue on. So down here I'd have 5 pi over 4, so that's 5/4. 6/4, right at the very bottom here, 6/4 can be reduced down to 3 pi over 2. 7/4, so that's 7 pi over 4. And last but not least, 8/4, and 8 divided by 4, of course, is just 2 pi. So right now we've covered off all our 45, 90, 135, anything that ends off with basically a 5 we covered off, and our extremities of the 90, 180, 270. The other ones in between though, let's start counting. So if I count this very first one as pi over 6, so I have pi over 6, this is now 2 pi over 6, and 2 pi over 6 I can reduce down to pi over 3, by the way. 2 pi over 6 is the same thing as 1/3. 3 pi over 6 is 1/2. 4 pi over 6 here is going to be reduced down to 2 pi over 3. 5 pi 6. And of course 6 pi over 6 is just pi, because 6 over 6 is just 1. Next up we'd have 7 pi over 6. 8 pi over 6 I can reduce down to 4 pi over 3. 9 pi over 6. 9 over 6 is the same thing as saying 3 over 2. This one here will be 10 over 6, and 10 over 6 can be reduced down to 5 pi over 3. And last but not least, we have 11 pi over 6 before we get back to here, and that's 12 pi over 6, and 12 divided by 6 of course is just 2. And so basically here's our unit circle almost filled in. We have all our degrees, all our radians. Now all we need are just our coordinates. Well, again, on a unit circle, the longest you could be is a radius of 1. So the longest, if I had a dot in the middle going all the way out to that edge there, my coordinate here, 1 and 0. So if this 1 and 0 is our radius, if you moved it all the way up here, now we're at 0 and 1. All the way to the left here, we're at -1, 0. And all the way at the bottom, we're at 0, -1. There we go. So now all we're left with is groupings of 3 angles to fill in each quadrant. So here's the fastest way to fill them in. It follows a pattern. And the pattern is all the 45s will always have a 2 for a coordinate. Everything else will have 1 or 3. So really I can go 2 and 2. Down here I'll start filling in later once I scroll my page down. As mentioned, everything else is going to be 1 and 3, but how do you know which one goes where? Take a look at your coordinates. If I have 1 and 0 here, the coordinate 1 means the very first number I should have for x here is going to be 3. Then the next one, 2, and the last one, 1. And I'm going to repeat that same process here. If I started with 0 for y, I'm going to be at 1, 2, 3. There we go. I'm going to divide everything by 2, by 2, by 2, by 2, divide by 2, and divide by 2, and square root every single numerator. Well, I can't square root 1 because it's just 1. So I'm going to leave that alone. I have a radical around 3, around 2, around 2, and around 3 again. There we go. So here, these are your exact values of the coordinates on your unit circle. Over here, we're going to do the exact same trick, but this time here, if we're in quadrant 2, all your x's need a negative next to them. So I have -1, -2, and -3 all going down the side there. All of it's going to be divided by 2. I have 1/2 here. This is divided by 2, divided by 2, and this is 1 divided by 2, so that means I'm missing a 3 divided by 2. Square root around everything that you need a square root, so square root, that negative's on the outside. This one's a bit too close, so I'm just going to clean this up just a bit. That negative has to be on the outside there, because you can't have a negative radical, of course. And there we go. That is quadrant 2, and that's a 1 right there. In quadrant 3, if you notice our coordinates here, -1, 0, 0, -1, everything's going to be negative. So let's go. Let's start filling this in. So I'd have negative root 3 over 2 with -1/2, negative root 2 over 2, and another negative root 2 over 2. And last but not least, I'd have 1/2 negative and negative root 3 over 2. There we go. Everything was negative. Over here, all our x's are positive, all our negative, or all our y's are negative. So this first one, root 3 over 2 and -1/2, root 2 over 2 and negative root 2 over 2. And last but not least, 1/2 and negative root 3 over 2. And there we go. That's our unit circle fully filled in. If you have a copy of this for your next quiz, you're allowed to use it. I'll give you a blank copy as well next class, and you can definitely fill one out, get that practice in, and you're good. Usually, my hint or trick to you, if you really know your coordinate systems of both positives, negative positive, negative negative, and positive negative for your x's and y's, all you really need to remember is quadrant 1, and all the other quadrants are the exact same numbers, just flipped signs. Off to example 1 here. If you have your unit circle handy, please have it out and ready to go. We're just going to pull the coordinates straight off of our unit circle. So if I'm at 60 degrees, I'm looking at the coordinate of, switch colors there, we're looking at the coordinate of 1/2 positive and root 3 over 2 positive, because 60 degrees is in quadrant 1. 7 pi 6 is in quadrant 3, so we end up with, sorry, there's an equal sign for b here, we end up with negative root 3 over 2, and if I have a negative root 3 over 2, the next pairing has to be a 1/2, because these two always go together, and it's going to be negative because again we're in quadrant 3. 240 is also in quadrant 3, so whatever my answer is, it's going to be double negatives again. So here this is negative 1/2 and negative root 3 over 2. 270, you're right on an axis, that's right at the bottom of the y-axis, so you're at 0, -1 there. 180 is also on an axis, that's to the left of your x-axis, so this is now -1, 0. Negative 5 pi over 4, this you got to count in clockwise, and so you'd end up in quadrant 2, and you'd be about 135 degrees there. So 135 degrees is also the same thing as saying negative root 2 over 2 and positive root 2 over 2. There we go. 23 pi over 6. So this one here, I'm just going to revert back to my unit circle and start counting it out. So if I needed to count to 23 pi over, what was that? That's 23 pi over 6's. I know that I have 1, 2, 3, 4, 5, 6 sixes to get up to pi, 7, 8, 9, 10, 11, 12 sixes to make one full rotation. If I'm 23, I'm short of 2 full rotations because 24 sixes would have been 2 full rotations. I'm at 23, so I'm just 1 less, so I'm at 11 pi 6, which is this coordinate right here, root 3 over 2 and negative 1/2. I went a little far there. So on this one here, our coordinate will be root 3 over 2 and negative 1/2 as mentioned. Last but not least, if you're looking for negative 3 pi, again, you would have started off on your x-axis going clockwise because it's a negative sign here. So we're going 1, 2, and 3. So we're at the coordinate, same as 180, -1, 0 as your coordinate. In example 2 here, it says find the measure of the rotation angle given this interval here. So whenever we state a domain, your answer has to be in that domain. This domain is between 0 and 2 pi, so your answer theta has to be between 0 and 2 pi for an answer. So looking on our unit circle, where are we? That's going to be negative for X and positive for Y, we're definitely in quadrant 2. So quadrant 2 is where we're at. There we go. And this one here says find the measure of the rotation angle. So you're really looking for, and I'll label it for you, in standard position, what is that angle? That's what you're really ultimately looking for. Let's call it theta. But before we get to theta, we need to find this angle on the inside here, our reference angle. So how do you find our reference angle? Let's jot down our two sides. Our x value was negative 1/2. Our y value, root 3 over 2. So to find our reference angle there, let's call it RA for reference angle. Reference angle is equal to tangent inverse, because we're looking for the angle, of our opposite side, root 3 over 2, over our adjacent side, negative 1/2. And so all I'm going to do is evaluate this on my calculator. This gets me, let's find out. So again, on my calculator, this is the first time we're using it. Make sure you're in degrees mode because we're using sine, cos, tangent. We're going tan inverse of our opposite side, which is, and let's throw that in brackets, or you can use the fraction function, totally up to you. I can switch it out to the fraction function there. So you have options right now. So sorry, I just lost my fraction function. So I got root 3 over 2 opposite over our adjacent side, negative 0.5 there, just for short. Close bracket, inverse, negative 60 degrees goes right in here. So my reference angle, so right now we're at, so this angle is negative 60 degrees. Before we write down reference, let's fill in that this angle was negative 60 degrees. Therefore, our reference angle is 60 degrees because reference is always between 0 and 90. So to find our rotation angle, you're just going to go 180 minus off 60, and that's going to get you 120 degrees in standard form, or in standard rotation. In example 3, let's put a box around that guy there, 120. In example 3, we want to determine one positive, one negative angle measurement for this exact coordinate. Well, if you're double negatives, you're in quadrant 3. So there we go. So you have theta is going to be right here. Your x value is negative root 3 over 2. Your y value is negative 1/2. So that would be P there for your coordinate point. So again, we want to find that angle there. So again, we're just going to run theta equals tan inverse of your opposite side, negative 1/2, over your adjacent side, negative root 3 over 2. And that's going to get you on your calculator 30 degrees. And so it says you want to find one positive, one negative to this angle. So to find this full angle, our full rotation right here, it's going to be 180 plus 30. So let's call this one theta in green now. Theta in green is going to be 180 plus 30, which equals 210 degrees. So if we know we're 210 degrees, that's going to be the positive angle. What's our negative angle? So to find a negative angle, we're just going to go 210 minus 360. That's going to get us an angle that's coterminal, and we get negative 150 degrees. There we go. In example 4, to find the smallest angle between these two coordinates, first off you got to find where they are. So again, I'm going to sketch it out really quickly. I know that this first one here looks something like this there, and the second one in red is in quadrant 4, and it's going to look something like this there in quadrant 4. Without doing too much work, I'm going to look up on my unit circle. This is about 150 degrees, so let's label that 150 degrees. So my angle here, 30 degrees reference. This one here was about, I believe, 300 degrees. And so again, I want to find, not the reference this time, I want to find this little sliver right here. That's also 30 degrees. A square here makes 90, so my smallest angle formed would be 30 plus 90 plus 30, which here equals 150 degrees. There we go. In this next part here, we have determining exact value. So exact value means no decimals. Okay, no decimals at all. So it says here the point on the unit circle corresponding to the trig ratio and the angles in standard position. Determine the exact value of sine 45. Well, first off, we got to find 45 degrees and the coordinates at 45 degrees. Well, 45 degrees is the same thing as saying root 2 over 2, comma, root 2 over 2. And if I was looking for sine 45, well, it doesn't matter which one I use. Well, it actually really is this one here. So sine 45 is equal to root 2 over 2. And there we go, and we are done. Another way to do this exact same question is to draw it out. And so I'm just going to split my screen there, and I'm just going to draw out a picture. So if I had this coordinate, root 2 over 2, root 2 over 2, that's in quadrant 1. So let's sketch out something in quadrant 1 here. Let's use a different color. There you have it, going straight down. There we go. And here let's start labeling this little triangle. So x would be root 2 over 2, y would be root 2 over 2. We have theta right here. And if you added these up and squared them, you'd have a hypotenuse of 1. So sine, which uses your opposite over hypotenuse, so sine 45 uses opposite, which is root 2 over 2. That's going to be divided by 1 because that's opposite over hypotenuse, which is still the same answer of root 2 over 2. There you go. So we have two different ways to get to this exact same answer. One way is to use our unit circle and recognizing that all y values will be sine 45, and so it matches up there. Second way is to graph it out, and that would work as well. And so here it says, remember it's alphabetical in your ordered pair, so all your x's, whatever your x comma y for ordered pair, all your x's are usually cosine related, all your y's are usually sine related. Tangent is a combination of sine over cos. On the next page here, we have about 12 questions to get through, and the way we're going to get through this is to look on our unit circle for these exact coordinates. So on your unit circle at 0 degrees, I'm looking for cos, which is 1 comma 0. So at 0 degrees, I have a coordinate of 1 comma 0. So cos theta, so therefore cos not cos theta, but cos 0 degrees is now equal to the x value there, so it's only equal to 1. So our answer there, just 1. Tangent, so again, I want to find out where 90 degrees is. 90 degrees is the same thing as saying 0 comma 1. Tangent, so therefore tangent of 90 degrees is equal to opposite over adjacent, or sine over cos, which is 1 over 0. And of course, if you type in 1 over 0 on your calculator, this will error out and you have, therefore, undefined. Because you can never divide by 0. In this next one here, we're looking at sine 60. So again, looking up where 60 is on our unit circle, you have the coordinate of 1/2, comma, root 3 over 2. Both are positive because they're in quadrant 1. So sine, therefore sine 60 is equal to root 3 over 2, because it's going to be all the y values. Sine of pi. So pi, the coordinate of pi is -1 comma 0. So therefore sine of pi has to equal the y value. That's going to be equal to 0. So for the next few here, I'm not going to write down the coordinates anymore. I'm going to assume that you're looking up the coordinates. On this one here, this is the same thing as saying, first off, 1 over sine 3 pi over 2. And 3 pi over 2, you're looking at the 270 degree marker. So sine there is equal to -1. Cos 5 pi over 3. 5 pi over 3 is right in quadrant 4 there. So the coordinate there is 1 positive, 1 negative, 1 half and root 3 over 2. So here, this one just works out to be, and I will write down a quick note. So 5 pi over 3 is the same thing as saying 1 half and negative root 3 over 2. And if I'm looking at cos, I'm looking at that 1 half. So therefore cos 5 pi over 3 should only equal 1 half. There we go. Tangent is a combination of your y divided by x. So at 3 over 4, 3 quarters pi there, you are at negative root 2 over 2 and a positive root 2 over 2. So your coordinates are negative root 2 over 2 and a positive root 2 over 2 because you're in quadrant 2. So again, tangent is the same thing as saying y divided by x. So if you divide them, you'll end up with just a -1 there. Over here, secant is the same thing as saying 1 over cos of 810 degrees. So this one here might be a bit tricky, but all you have to do is just keep going around in your unit circle. You'll end up with a coordinate of, and 810 gets you to a coordinate of 0, 1. Cos is going to be that x value, so this is now just really 1 over 0. Therefore, you are undefined. On H there. For I, again, we're working with secant, so this is the same thing as saying 1 over cosine 5 pi over 4. There we go. Again, I want to look up 5 pi over 4. That's the coordinate of root 2 over 2 negative and another negative root 2 over 2. Cosine's just going to be the first one there. So this is now 1 divided by negative root 2 over 2, which gets you to negative 2 over root 2. Rationalizing top and bottom, you end up with negative 2 root 2 all divided by 2, and your 2's cancel out on the outside here, on that outside, and that 1 in the bottom. This one here you can't cancel out because it's in radical, so you end up with ultimately negative root 2 for an answer. 315 is the same thing as saying root 2 over 2 positive and a negative root 2 over 2. So again, tangent is y divided by x, which is just ultimately -1. Cotangent on this one here is x divided by y, because it's the reciprocal. For -4 pi over 3, you'd have to go in clockwise rotation until you get to 3 over 3, which is pi, and then one more, 4 pi over 3. So you're looking at that 120 degree marker, which has a coordinate of -1 half and positive root 3 over 2. There you go. So we found the coordinate. We're looking at cotangent, which is 1 over tan of -4 pi over 3. And again, tangent is just your opposite over adjacent, which is your y over your x. So let's write that down. So this no longer is here, so this is 1 divided by root 3 over 2. Let's do it sideways. All divided by -1 over 2. So cleaning all this up here, you're left with -1 over root 3 Again, we don't like that root 3 there, so I'm going to rationalize, not reciprocate, rationalize top bottom by root 3. So now I have negative root 3 up top, all divided by 3 in the denominator, and that's going to be my answer there. For L, pi over 2 is the same thing as saying 1 comma 0 for coordinate. Oh wait, no, 0 comma 1, sorry. I have my coordinates in the reverse order. That's 0 comma 1. There we go, that looks a bit right. Cosecant is the same thing as 1 over sine at pi over 2. Sine is just 1 there, so this is now 1 over 1, which is just ultimately 1. In example 7, we're just going to try to find the exact value of each expression. So again, you're looking up what sine at pi over 4 is. At pi over 4, cosine is root 2 over 2. And I have a subtraction sign in between them. And I got to find what sine pi over 6 is. At pi over 6, sine is equal to 1/2. If I subtract these two here, I can't really do anything except for combining common denominators. So that's what I'm left with is root 2 minus 1 in numerator, all divided by 2. On this one here, we're going to do a bit of more work here. At 30 degrees, tangent is the same thing as saying 1/2. All of that's divided by root 3 over 2, and of course tangent was all squared, so we have our square there. Secant is 1 over cos 45, and at cos 45 we are at root 2 over 2, and all of that's going to be squared. Cleaning all that up, we're left with, on the left side here, 1 over root 3 all squared, and on the right side this is now 2 over root 2 all squared. Right now I'm not going to really worry about my denominators with the rationalizing of denominator there, because that squared is going to take care of it for us. So here on the left we have 1/3, there on the right it's going to be 4 over 2. Multiplying fractions, you get 4 over 6, because you go top top, bottom bottom, multiply together, which is now just ultimately 2 over 3 for an answer. Last but not least, number 8 is typing all 3 in on your calculator. So let's work with our calculator. The very first thing, double check your mode. So if I didn't change my mode, if I typed in sine 5 pi divided by 12, I would have gotten an answer of 0.0228. So let's jot that down. So in degrees mode, we got 0.0228, which is absolutely wrong. That's the wrong answer. We want to switch modes. So hit your mode button, go down to radian, hit enter. You want to be in radians because I see a pi there. So again, typing in this exact same question now, but in radian mode, we get 0.97 if you had to round it. So in radian, we're at 0.97, and that is the more correct answer. Here, cos 750 degrees, and again, there's a degree symbol there, so I want to switch back into degrees. There we go, hit enter on there. You want to go cos 750. And again, doesn't tell you how many decimals to round to. I'm just going to go to 2. So this here is equal to 0.87. There you go. Last one here, cosecant 2 pi over 3. Again, if I'm seeing a pi, I got to switch back to radian there. Cosecant is 1 divided by sine. That's what cosecant is. I have my 2 pi over 5 there. So my answer to 2 decimals, 1.05. And that's how you'd use your graphing calculator. If you have any questions about today's lesson, please feel free to ask.